Hey class, for homework tonight, we are going to be taking notes, and this is going to be on page 285 in our binder, and we're going to be talking about solving systems of equations by elimination. This is going to be our third and final way that we're going to be able to solve a system. All right, so how can I solve a system of equations by elimination? Well, the answer to that is with adding or addition. Right? We're going to need to add our two equations in order to solve our system. All right, so let's look at our first example and fill out this chart. All right, so we have our system of equations of 5x minus 6y is equal to negative 32, and x plus 2y is equal to 16. All right, so kind of our pre-work or our step 0 here is to make sure that we line up our variables, right? We want our variables in standard form so that ax plus by equals c. All right, and if we look at our two equations, right, they're in that form, right? So we have our first equation of 5x minus 6y is equal to negative 32, right? That's in standard form. And then our second equation of x plus 2y is equal to 16. That is also in standard form. All right, so now our next kind of major step here is to determine which variable to eliminate. When we kind of look at that hint there, we may have to multiply one or both of our equations by a value in order to eliminate. All right, so if we look at these two equations, right, I definitely can't just add them up the way they are because neither one of my variables will eliminate. So then you have to decide which variable you're going to eliminate and how are you going to be able to do that. Well, if I see these two equations, right, to me, I want to eliminate that y variable. All right, so I'm going to decide to eliminate the y's. All right, and in order to do that, I'm going to have to multiply this second equation by some number, right? And that number is going to be 3. And the reason why I want to multiply that second equation by 3 is that so I can get that coefficient on my y to be a positive 6, because I need opposite coefficients on the same variable. All right, so now I'm going to rewrite kind of both of these equations, right? This first equation I didn't touch, right? 5x minus 6y is equal to negative 32. And now when I multiply that second equation by 3, I'm going to get 3x plus 6y is equal to 48, right? By multiplying by 3, I just created opposite coefficients on the same value, right? My negative 6y and my positive 6y are now going to eliminate once I add up these two equations. So we're going to get 8x. My y's are going to be eliminated equals positive 16, right? A negative 32 plus 48 gives me a positive 16. And then that 5x plus 3x is 8x. All right, so I eliminated my y's. Now I just got this little one-step equation here to solve for x. All right, so we can divide by 8, and we get x is equal to 2. So I just solved for my first variable. And now I got to get that other variable, right? Because remember, a system of equations in order to solve, right, is going to be an x-y coordinate pair. All right, so kind of just like in the previous method with substitution, right, I'm going to have to substitute this value into one of the original equations and then solve for the other variable. All right, so again, I'm going to look back up and kind of decide which equation I'm going to use, right? I'm definitely going to use that first equation, right? That x plus 2y is equal to 16, right? That's kind of the easier looking of the two equations, right? So now I'm just going to substitute in that x equals 2 for x. So then you get 2 plus 2y is equal to 16, right? Minus 2 to both sides. Continue my work over here. So I get 2y is equal to 14, right? We divide by 2, and we get y is equal to 7. So that should be my solution here, right? 2 comma 7. However, I'm going to be a good mathematician here, and I'm going to go ahead and go check my work here. All right, so I'm going to plug in 2 for x and 7 to y for both equations, right? Because I want to make sure that this is true for both equations and that I did my work properly here, right? So my first equation was 5x minus 6y. So now it's going to be 5 times 2 minus 6 times 7, right? So we get 10 minus 42, which is negative 32, right? Negative 32 equals negative 32. Check. It worked out for my first equation. And now I'm going to do the same thing, make sure it works out for my second equation, right? X plus 2y is equal to 16. So x plus 2 times y. All right, let's make sure that equals a positive 16. So 2 plus 14, 16 equals 16. Check. It works out here. All right, so those are the steps to solve a system of equations using the elimination method. So let's go ahead and do a couple more example problems together here. All right, so we're going to look at the top of page 286 now. This is example 1. We're going to work through these 4 examples here, and that will be kind of the homework for today. All right, so let's look at example 1a here. This is my system of 2x plus 5y is equal to 17, and 6x minus 5y is equal to negative 9. Well, let's see, they're both lined up, right? They're both in standard form. So now I'm looking at the system here, and I'm going to have to decide on which variable to eliminate. This decision is going to be relatively easy to make because I do have that opposite coefficients on the same variable, right? I have a positive 5y and a negative 5y. So I'm going to go ahead and eliminate that y variable. All right, so again, I'm just going to need to add these 2 equations up, and my y's will eliminate here. So we get 2x plus 6x gives me 8x, right? My y's eliminate, and then we get 17 plus a negative 9 is a positive 8. So now I'm going to solve for x, right, by dividing both sides by 8, and we get x is equal to 1. All right, so I solved my first variable. Now I need to go ahead and solve that other variable. So again, I'm going to look at my system here. I'm going to decide which equation kind of looks the easiest. I'm going to say that first one does. So I'm going to use that, and I'm going to substitute 1 for x. So I get 2 times 1 plus 5y is equal to 17. Right now, I just got to solve for y here. Right, I'm going to subtract 2 to both sides. And we get 5y is equal to 15, which means y is equal to 3. Right, so I should have a solution of 1 comma 3 because it's an xy ordered pair. But again, I'm just going to go ahead and check just to make sure that this is the correct solution here. All right, so I'm just going to do a little work here on the side. Right, 2 times 1 plus 5 times 3. I just want to make sure this adds up to 17. 2 plus 15, yep, 17 equals 17. That checks out. I'm going to do the same thing for my second equation here, right? 6 times 1 minus 5 times 3, right? That's 6 minus 15. Yep, that gives me negative 9. So it checked out. All right, let's go ahead and look at example B here. All right, example B, I have 8x plus 11y equals negative 20, and x minus 11y equals negative 59. Well, again, look at this. They're both kind of lined up. They're both in standard form. I'm lucky again, and I have the opposite coefficients on that same variable. I get a positive 11 and a negative 11y. So that means I'm going to first eliminate that y variable. Right, I'm going to eliminate that y variable by adding these 2 equations. So then we get 8 plus 5x is 13x. Right, my y's are eliminated, equals negative 39, right? 20 plus a negative 59 is a negative 39. So now I divide both sides by 13, and we get x is equal to negative 3. All right, again, I'm going to solve for my x. I got to get that y variable now. So I'm going to look at both of my equations in that system, and I'm going to go ahead and use that top one this time because that one looks a little bit easier to work with. So I'm going to do 2 times negative 3 plus 11y is equal to 20. So we get negative 6 plus 11y. Oop, that's not 2 times negative 3. That should be 8 times negative 3. Where did I get that 2 from? So this is negative 24 plus 11y is equal to 20. I'm going to add 24 to both sides. And we get 11y is equal to 44, which means that y is equal to 4. So my solution should be negative 3 comma 4. I go ahead and, kind of check and make sure that that works out. So let's see, 8 times negative 3 is negative 24. Plus 11 times 4 is 44. So negative 24 plus 44 is going to be positive 20. All right, that works out for the first one. And then that second one, 5 times negative 3, well, that's negative 15, minus 11 times 4, well, that's minus 44. And that gives me negative 59 equals a negative 59. So that kind of checks out, right? So you can just do a quick little mental math to make sure that that solution works. All right, we got 2 more examples here. All right, example C. We have 20x plus 3y is equal to 20, and negative 20x plus 5y is equal to 60. All right, again, these are lined up, right? They're in standard form. Again, I'm getting kind of lucky here. I've got 3 in a row that my variables are opposite coefficients of each other on that same variable, right? I got 20x and a negative 20x, right? So those are going to be eliminated first. All right, so this time I'm going to eliminate those x variables. Right, again, I'm going to add these 2 equations up, and now my x variables are going to be eliminated. So now we're dealing with a positive 3y plus 5 more y's is 8y is equal to 20 plus 60 is 80. Right, we divide by 8 both sides, and we get y is equal to 10. Perfect, so I solve for y, now I have to solve for x. I'm looking at my 2 equations and I'm saying, oh yeah, that top one looks a little bit easier. So I'm going to use that top equation now to solve for x. So we get 20x plus 3 times 10. Right, I'm using what I solved for my first equation to substitute that in, equals 20. So now we get 20x plus 30 equals 20. Right, subtract 30 to both sides. And we get 20x is equal to negative 10, divided by 20. And this time we get x is equal to negative 1/2. All right, so we get negative 1/2 for x. Y is 10. So therefore my solution is negative 1/2 comma 10. Right? We might not always get those whole integers when we're doing our system of equations, right? Sometimes we won't get fractions. All right, so again, let's just double check that our fraction answer kind of works and makes sense here. Right, we're going to do that by plugging it back in. 20 times negative 1/2, that gives me a negative 10, plus 3 times 10 is 30, right? So negative 10 plus 30, yep, 20 equals 20. That worked for my first equation. I'm going to do the same thing and plug those negative 1/2 and 10 into that second equation. So negative 20 times negative 1/2, well, that gives me a positive 10. And then a 5 times 10 is 50. Right? 10 plus 50 is 60 equals 60. Yep, that worked out. So therefore, my solution is negative 1/2 comma 10. All right, last one here. Letter D. I have 7x plus 2y is equal to 10, and y equals 7x minus 16. Okay, this system, right, is not in order, right? I gotta line these up. That first equation, that's in standard form, right? But that second one is not, right? So in order to get that second equation into standard form, right, we would subtract 7x to both sides. So now that second equation is going to be negative 7x plus y is equal to negative 16. Right, then I'm going to simply rewrite this one by subtracting that 7x over, and I get negative 7x plus y is equal to negative 16. All right, in that first equation, I'm just going to go ahead and drop it down so that it's lined up. All right, so now my equations are lined up. They're in standard form. Oh, and look at that. My x's are opposite of each other, right? They're opposite coefficients, so therefore my x's are going to get eliminated. And they're going to get eliminated when I add up these two equations here. Right, my x's are eliminated. I have a positive y plus 2 more y's is 3y is equal to negative 16 plus 10 gives me a negative 6. Right now, I know I divide by 3 to both sides, and we get y is equal to negative 2. And now I go back up here, and let's see, again, I'm going to pick that first equation. It's a little bit easier to work with to solve for that x variable. So we say 7x plus 2 times negative 2 is equal to 10. So 7x minus 4 is equal to 10. Right, we add 4 to both sides. And we get 7x is equal to 14. Divide by 7. And we get x is equal to 2. So therefore, my solution for this system is 2 comma negative 2. Right, it's always x comma y. All right, you can go ahead and pause the video and kind of do that mental math on your own to check the answer. And that's going to be it for the homework tonight.